Differential calculus. Can we deduce equation of a line through differential calculus? Calculus is integral and calculus is differential. Two calculus. So differential calculus is nothing but rate of change. Integral calculus is nothing but addition. Inverse of rate of change is summation. So if we need to calculate summation through area, through area, then it is integral calculus. If we need to calculate the rate of change, then it is differential calculus. So for linear equation means if there is an independent variable x, then there is a dependent variable, then there is a dependent variable fx. A function on x is dependent variable. So if there is an independent variable x, then there is an independent variable x, then there is a dependent variable fx. We consider fx being orthogonal to x. So this is the most crucial. If fx is orthogonal to x, then if x direction is I, then we consider fx direction as j. If x direction is x-axis, then fx direction is y-axis, z-axis, whatever. It is orthogonal to x. So we can say that fx is y, y equal to fx, y equal to fx. So if fx being independent variable, x being independent variable, fx, the function on x, is dependent on x, and function of on x that is orthogonal to x is nothing but we can consider as y. So y equal to fx. So y is dependent upon x. Now there are two things, x and y. X and y, two variables, though they can lie on a plane. I consider xy plane. Now for a linear equation where y equal to or fx equal to x to the power 1, okay, line, plane term, straight line. So can I deduce equation of a straight line through differential calculus? Okay. Now suppose I have 2 points. I have 2 points. One point is 0, 0. Another point is 2, 3. A line passing from 0, 0 and 2, 3. Differentiation is nothing but rate of change. So dy by dx per unit of change in x brings how many unit of change in y at any point on the line. Since it is a linear equation, it would be same at every place in the line. Line is a straight line. dy by dx per unit of change in x, how much per how much unit of change it brings in y. Unit can be very small, big, whatever. So if line is curved or it is non-linear, then we consider it as very, very infinitesimal small the unit. In that case, we consider if unit is very small, so maybe 1 micrometer, then how many micro, if 1 micrometer x changes, then how many micrometer y changes at that point, then that equation is considered as differential uh, differential equation which is differential, which can be differentiated at that point. So these are the terminology. Now I have a line that passes through 0, 0 and 2, 3. What is the equation of the line? That is the question. Now the change in x is 2, which brings change in y as 3. 0, 0, 2, 3, 0, 0, 2, 3. A line is there like this. Then per unit change in x brings per brings some unit of change in y, that is 3. If 2 unit x changes, then 3 unit in y changes. So per unit change in x brings 3 by 2 unit change in y. So 3 by 2 is the change in y. So dy by dx equal to 3 by 2. Per unit change in x 2 brings 3 unit change in y. 3 by 2 is the dy by dx. If 3 by 2 is the dy by dx, can I say y equal to 3 by 2x, because that is the differentiation. So differentiation is nothing but, if it is a linear x to the power 1, then dy by dx means x to the power 1, so x would go. So that comes as 3 by 2. So if I do per unit change, that becomes dy by dx, and that is the equation of line. So we calculated equation of the line as y equal to 3 by 2x. This is through differentiation, the back to top, bottom to up, we calculated the equation of the line. This is the way we can show now y equal to 3 by 2x. Now if this is the line, then line would intercept somewhere. So this is the axis, x and y. So line is passing through origin. Now, but this is a line. Line we can consider as a direction vector, but line can anywhere. If dy by dx is same, means slope is same, gradient is same, but line we can shift. If I shift on left side, it would cut somewhere on the x-axis, and it would cut somewhere on the y-axis. So if this is y, this is x, this is origin, line is passing like this through origin. If I shift the line left, it would cut y-axis and x-axis. If I shift line to the right, it would cut x-axis. Slope is same. So if I go through slope fundamentals, dy by dx, then we have not considered the cuts, where the cut would be on x-axis and y-axis. Suppose that there is cut on x-axis, that is x0, and there is a cut on y-axis, that is y0. Then how we can find the equation? So now can I say y equal to mx means y minus 0 equal to mx minus 0? Correct. So y minus 0 equal to m is the slope dy by dx what we have calculated. Y minus 0 equal to dy by dx, that is slope, into braces x minus 0. If that is true, then x minus 0, it intersects x-axis at 0. Y minus 0 equal to dy by dx braces x minus 0 means y is intersected at 0, x is intersected at 0, means line passes through origin. If line passes through y0, or I say beta, y minus beta equal to dy by dx x minus alpha. If it is like this, so if this is the line, if line I shift right and it crosses the x-axis at alpha, then then earlier y was 0 when x was 0. Now y is 0 when x is alpha. If that is the case, then x become x minus alpha, because if x become alpha, y is 0. So y equal to dy by dx x minus alpha. If y we shift right, x line we shift right, and it intercept x-axis at alpha. Line I shifted towards right on x-axis. Now line, this is the line I'm shifting towards y-axis. Okay, so if that is the case, now we went y. y minus beta equal to dy by dx x minus alpha. So if I am shifting the line toward y-axis, then if y is beta at that moment, x is 0. Earlier y is 0, then x is 0. Now line shifted up to beta, and when y is beta, then it is 0. X is 0. If that is the case, if y is 0, then x has some value. So y minus beta equal to dy by dx x minus alpha. Now that is the equation of line. Y equal to beta plus dy by dx x minus alpha, where alpha is the intercept on x-axis and beta is intercept on y-axis. Now we had line that passes from through origin and 2 comma 3. So that is the, now I consider that line is passing 2 0 on x-axis, 2 0. Line is passing on x-axis at 2 0. If that is the case, then x is 2 and y is 0. Y minus beta means y minus 0 equal to m x minus 2. So y equal to m or dy by dx x minus 2. Y equal to 3 by 2 x minus 2. That is the equation. Suppose line on top, line we shifted up from the origin and it is passing y at 3. Then at that moment x is 0. Y minus 3 equal to 3 by 2 x minus 0. So y minus 3 equal to 3 by 2x. Y equal to 3 plus 3 by 2x. Okay. So this is the pretty nice concept if we want to deduce the equation of a line through differential. Okay. So for linear equation, if I know dy by dx and any point I know, then I can fit into y minus beta equal to dy by dx x minus alpha. This is 1D. I mean in one plane, in xy plane. What about 3D surfaces? So we talked about